All right, you'll remember now that on the last slide we derived this formula, and we know that for the when these two terms of our total annual inventory costs are equal to each other, that generates the minimum total annual inventory cost given an order value of Q, which is what the unknown that we're trying to solve for. And so setting these equal to each other and then solving for Q gives us this formula: square root of 2 times the annual demand times the ordering cost divided by the carrying cost. Okay, remember this is our, and this is my term here, a sawtooth model, right? And we're able to, once we know this Q, in fact, we're going to actually calculate Q star, then we can determine all of these various components. We can determine the number of cycles or how many orders. We can determine the reorder point. We can determine the cycle time, and also we can determine the total annual inventory cost. So let's take a look at an example, 13.4 for the Sofa World problem that you'll find on page 575 of your textbook. And I'm going to read it to you. Sofa World company purchases upholstery material from Barrett Textiles. The company uses 45,000 yards of material per year to make sofas. The cost of ordering material from the textile company is $1,500 per order. It costs Sofa World 70 cents annually to hold a yard of material in inventory. Determine the optimal number of yards of material Sofa World should order, the minimum total inventory cost, the optimal number of order per year, and the optimal time between orders. All right, so let's take a look. The first thing that we need to do is to determine the various components of our model. And we know that we're given the following. The annual demand is 45,000 units. We know that the cost of ordering is $1,500. We know the carrying cost we're given is 70 cents per yard. And this is 45,000 yards. And so the first thing that we're asked to order is determine is the EOQ. And so we know that by our EOQ is going to be the square root of 2 times D times CO divided by the carrying cost. And again, all of this is under the radical. And of course, when we substitute in square root of 2 times, I'm not going to write all of these zeros, but it's 45,000, 45K, times C sub O, which is 1,500. And all of that's going to be divided by 0.7. And when we do the arithmetic, we're going to find out that our Q star is 1,388,187 yards is the amount that we're going to order each time. Next thing that we want to know is I'm going to skip the minimum total inventory cost and go to the optimal number of orders per year. How many orders per year? And if you remember, again, this is answer number one. Number two, then answer average number of orders per year is the annual demand divided by this optimal order quantity. And once we substitute in our values, 45,000 is the annual demand divided by 13,887. That's going to be equal to 3.24, just over 3 1/4 orders. Okay, the next thing that we want to determine is the following. The optimal time between orders. So let's think about our model. Here's our sawtooth model, if you will. It's not very, lines are not very straight. But we know that we have, in this particular situation, we have, in a year, we have one cycle, we have a second cycle, and then we have a third cycle, and then we have part of another cycle in that year. And so the question is, how many days are we operating? And we're not really told exactly how many days, but if we assume that we're operating 365 days a year, and we know that we have 3.24 orders during the year, then the time between each order, since each of these little cycles is constant, is going to be 113 days. And then lastly, I'll come back to the total cost. And total cost, and I should say it's actually the total, I'm going to insert here, total annual inventory cost is going to be D times P plus our Q star. Oop, let me start over. That didn't. Total annual inventory cost is going to be D times P plus Q over 2 times the carrying cost plus D over Q star times our holding or ordering cost. And these are optimal order quantities that we've already. Now, again, you'll notice we're not given this value of P, and so we don't need to include this component. So what we do want to do is use our other information, and this is going to be 13,887 over 2 times our carrying cost, which is 70 cents. And this is, of course, we already know what this is because we've computed that, which is 3.2 orders times our ordering cost, which is 3.24 times 1,500. And if the arithmetic is correct, this value will be exactly equal to this value. And it turns out that this is going to be, each term is going to be $4,860 plus $4,860, which is $9,720. So our annual inventory cost is $9,720. The last thing that I want to point out here is the following. Even though, let me use a different color, even though this order quantity, 13,000, is the optimal order quantity, in very practical terms, this company will probably order 14,000 yards rather than 13,887, because this will generate a cost that's more, but not very much more, and it's more likely that the supplier can fill 14,000 rather than this particular odd order. So that that takes care of the SOFA world SOFA problem. You might want to ask yourself the other questions. What's the average annual inventory that's on hand? There's not given a lead time, but you want to think about the lead time and how you would calculate the lead time. And the not calculate the lead time, but calculate the reorder point if you had the lead time. Okay, as with anything, this concludes the lesson, but if you have any questions, don't hesitate to contact me.